Well, good morning and good afternoon, everyone. Welcome to another exciting Exploring by the Seat of Your Pants broadcast. There are so many new faces in the crowd today, and so if you are new to us, including our speaker, we are all about bringing conservation, adventure, and science into classrooms around the world. And this marks program number 3, woohoo, in our epic new Canadian Space Agency series highlighting the coolest scientists and explorers in Canada working to understand more about the mysteries of our cosmos. So I'm going to dive into a little bit of an introduction to Patrick in just a second, but I do want to note there will be a Kahoot today. So between our talk and our Q&A, if you want to play along with a little 4-question quiz to test your understanding and have some fun, you can pull up that game pin and do just that. Now, I'm really excited today because we are talking about one of my favorite missions in the history of the world, which is the Curiosity Rover, the Mars Science Laboratory. You kids are growing up in an era where you can literally go online and look at active images and videos taken on another world. The fact that we can send robots to another planet and go exploring is just magical. It's one of the coolest things ever done on planet Earth and beyond. And so I'm really excited you guys get to hear about it today. And joining us to explain a little more about it is Patrick Hill, who has the awesome job title of Mission Scientist in Planetary Exploration. If there's a cooler job title than that, I don't know what it is. He gets to play around with a Canadian science instrument on Curiosity, which is the Alpha Particle X-ray Spectrometer, which sounds like the coolest science instrument of all time. So we're going to learn a little bit about that, the mission and beyond. I'm so happy you're all here. And without further ado, Patrick, thank you so much for joining us today, man, and welcome to the broadcast. Take us away.
Thanks so much for having me, and thank you for that kind introduction. As was highlighted, my name is Patrick Hill. I'm a mission scientist here at the Canadian Space Agency, and my background is in geology. So I work with, love working with rocks, whether they're from the moon, Mars, or asteroids. And I'm here today to talk about Mars and the Curiosity Rover. And specifically, I want to highlight the Canadian contribution and what Canada is contributing to the mission, and how we're helping advance our understanding of Mars, both its past and its present. So before diving into the mission as itself, I thought what would be great is to highlight why we explore Mars, why Mars is super, super cool and interesting, and why planetary scientists like myself and others are excited about missions such as the Curiosity Rover that are exploring the surface. And as a geologist, when we look at the surface of Mars, we look at this image, even just this image here, we see a planetary body that is truly, truly exciting because we see a lot of different geologic processes. So Mars is covered in a lot of sand and is dusty, and perhaps it reminds you of Tatooine from Star Wars or something like that. What we also see are these really cool geologic features, like these impact structures, these dots, these circles on the surface, or Valles Marineris, this large canyon feature that we see right in the beginning. And that indicates that we have a planet that was truly dynamic and being modified in the past, and is something that as geologists and planetary scientists, we're truly interested in exploring more about. So to dive right in, just to give you some context of where we are in the solar system, today we're exploring Mars and talking about the Curiosity Rover. Mars is the 4th planet from the Sun and has an orbit that varies in distance from Earth. So at its closest point to Earth, it's about 4.6 million kilometers away. But when it gets to its furthest point away, it's about 400 million kilometers away. And when we explore planetary bodies like this has implications for how we do missions. So it takes about 9 months when the orbit is best aligned to get from Earth to Mars. And so this alignment happens about every 2 years. And so if we do missions on the surface of Mars, we usually launch things. It takes 9 months to get there-ish, and then it takes another 2 years until we can do the same or things can come back. But as I said, Mars is truly, truly exciting, and there's some similarities and differences with our own planet. So we can talk about its orbit around the Sun. It's significantly longer than the Earth, about 687 days instead of 365. But its day is quite similar. It's about 24 hours and 39 minutes. It has a lot of similarities in terms of geologic features and processes. For example, it has mountains. It has the largest mountain in the solar system. That's 26 kilometers high, which is 3 times the size of Everest. We have water that we know exists. This exists differently than the Earth, however, as it's mostly formed as ice and vapor, and we don't see pure liquid water on the surface like we do here on Earth. It has weather and temperature, and because of its thin atmosphere, its temperature can vary significantly, and that is also the reason why we don't really see pure liquid water at the surface. The temperature can get down to as cold as minus 100 degrees Celsius in the night, but it can get as warm as 20 degrees in sunlight at the equator, so it's quite various. The key thing that we really need to take away is that, in terms of size, Mars is significantly smaller. So it's about half the size of Earth and 1/10 of the mass, and that will be critical in a little bit. So as I said, as a geologist, we really love studying Mars, and the way planetary scientists often like to look as they explore other planetary bodies is to relate them to Earth, because we know Earth best as geologists. We can go explore it and we can go see it. And so we can do what we call as comparative planetology to understand what is happening. So in the top left, I have Olympus Mons. That's that highest mountain that I talked about. It's actually a volcano. So I don't know if many of you have been to Hawaii or know of Hawaii, but this is very similar to the shield volcanoes that you see there. It has a north polar ice cap, as seen on the right, which is mostly ice, but also some carbon dioxide. You can think of dry ice if you've ever worked or seen that on TV. And then Valles Marineris is that massive canyon that I talked about at the very beginning. So it's similar to what we think about for the Grand Canyon, but it's much, much, much bigger. So this canyon system is about 4,000 kilometers long, 200 kilometers wide, and 7 kilometers deep. If you were to put the continental United States, it would be about the same size. So it's completely different. So we see a lot of geologic processes and we see a lot of interesting things, but the truly exciting fact about Mars is this notion of a habitable zone. And so a habitable zone is defined as where liquid water would be stable at the surface of a planet around a star if it was the same size as Earth. And so Mars is right on that boundary, and it falls within it depending on the modeling. And that's really interesting. But the fact is that Mars is not the same size as Earth, as I just said. So what we have is this bit of a complicated story. We have this potential for liquid water, but there's the size issue. And so when we study Mars from orbit or on the surface, we see that there's this evidence that maybe liquid water was flowing on the surface. So here in this image, we can see river valleys or channels where a liquid has directly been involved in the formation. And so we know by studying Earth, this is how they form. And so we get really excited because in the context of habitability and life in our solar system and life elsewhere and life on Earth, what we believe based on studying Earth is that water is critical. So if we want to explore other areas, other planets to maybe find where life could exist or could have exist, we need to do what NASA calls following the water. And so the fact that Mars has this evidence of past life makes it very, very exciting for different missions and exploration targets. Now, the amount of water is heavily debated. There's some people that argue that the northern hemisphere could have been filled with a large ocean similar to what we have here on Earth, but others argue that maybe it's more just lake intermittent melting of glaciers and ices and things like that. But we do know that water played a key role in the first billion years of Mars's existence. And that's really, really exciting, as I said, for sort of exploring where potential life could exist or could have existed in our solar system. And so what different space agencies have done is begin to explore the surface in different ways. And we can explore planetary bodies in a bunch of different ways. And the first way you can think of is satellites. So on Earth, we use satellites for observing the surface, for weather, for different features like that. And we can do the same for planets like Mars. And so we have images that take images of the surface, analyze the atmosphere, but also can do things like determine variations in chemistry and what the rocks are and what the distribution of different geologic areas of interest are. In addition to that, we have what are called landers in the top left. And so these are stationary platforms that land in a single point and do science in those single locations. In this top left example, this is actually a digital rendition of the Phoenix Mars mission. And Canada was also part of that mission. And in a very Canadian way, we contributed to the weather station on board, including a device that measured the first detection of snow on Mars, which I think is just a super cool, very Canadian discovery to make on another planet, especially in January, as most of you are probably experiencing snow. And those landers are great, and they're really great for exploring the surface of Mars. But what geologists love is to get about and look around and explore the rocks. And so space agencies like NASA have begun sending rovers, and these are robotic missions that are able to explore the surface and look at the variations of the rock to look at not just one single location, but multiple. And that way we can study the chemistry, the distribution of rocks, what they look like, how they vary in different spots, to get a sense of the environment, both spatially and through time, to get a real sense of what's happening on the planetary body. And so in that last image, I was showing you a generated image of the Spirit and Opportunity rover. But what Canada has also contributed to is the Curiosity rover. This is part of the Mars Science Laboratory, and this is a significantly larger rover than the Spirit and Opportunity rovers. It's about 900 kilograms in mass, so it's already about a ton in mass. And in terms of size, it's about 3 meters by 3 meters and then 2 meters high. So it's practically like you're driving a small car that's very heavy on the surface of Mars. In addition, compared to the last rovers, they were all solar powered, whereas this uses what we call an RTG, so it uses nuclear power, and that gives it a bit more of an oomph in the mass and what it's able to investigate with. And so it was launched in 2011, so over a decade ago, and then because of the 9 months, it landed on the surface of Mars in 2012 in August, and it has been exploring the planet Mars since for its geology and habitability. And the place that NASA chose to send it is Gale Crater, which is this large impact crater highlighted in the image. Impact craters are when asteroids or large space rocks smash into the surface of another planetary body, and they cause a large amount of energy release, and they can move a lot of rocks, and they can make these structures. So it forms a large bowl, and then because of the nature of the impact, there is uplift at the middle. So you get this bowl-like structure that's quite flat at the bottom, and then this mountain in the middle called Mount Sharp, which is about 5.5 kilometers high. And so while it looks dusty and dry now and is covered in sand, from orbit, what the scientists were able to determine is that there was probably evidence of past water, because they were able to identify rocks and minerals and evidence to suggest that water had hydrated and interacted with the material. And that made it super, super excited, as I said, because we want to follow the water and evidence of water to look at the habitability and the biological potential of Mars. And so while this crater formed 3.7 billion years ago and has been dried for most of its existence, it's a really exciting place to look at where potentially life could have existed and what habitable environments look like in the solar system. And so the size of this basin, just for context, is 154 kilometers wide. So for people in Ontario, that's a little under the distance from Toronto to London, or it's similar to the distance between Calgary and Red Deer and places like that. So in terms of mission objectives, the goal of this mission was really to assess the biological potential at the landing site. So this is the ingredients for life being present, the preservation potential, what is the environment like in the past, and would there have been life there? Characterize the geology of the landing site, so understand what processes are shaping this amazing and dynamic landscape, and what is modifying the surface, and what that means for life in the ancient Mars and the potential for it, and where it could be could have existed. And then taking that into context, we can investigate planetary processes that shape the habitability and the potential for life to exist, because we want to understand where life could exist and what that environment looks like and what ancient Mars would have looked like. And so the goal of MSL and the Curiosity rover was not to discover or find life, but really to follow that water and look at the environment and what is the potential there. There is this fourth objective, which is a bit more of a forward-looking objective because it's to characterize the radiation environment. And the driver behind this is really because in the end, in future decades, space agencies would like to send humans to the surface to Mars, and understanding radiation is critical for understanding astronaut health and their ability to exist and operate on the surface in a safe manner. And so how do we explore and address these mission goals? So what these rovers are is pretty much like a comprehensive mobile geologist on wheels. So what they try to do is give a rover everything that a geologist in the field would want to do and do in their lab. Obviously, they can't send giant laboratories because they'd be super, super heavy. And so they try to do that by optimizing mass at the same time. And so there's a bunch of instruments, as highlighted here, to do a bunch of different things. Some key ones are the cameras. As it was mentioned, you can go look up at images and videos of Mars and active exploration that's happening now. And these are captured by the mass cam, the nav cam, and the hazard cams to be the eyes of the rover. So it allows it to drive safely with the hazard cameras, but also take detailed photos that we can study for understanding different geologic processes. The robotic arm also has an imager that can take microscopic images called MARLI. And then there's a full suite of science instruments. And so this is tools that the science team can use to understand what is happening in the surface. So we have things like ChemCam, SAM, ChemMin, APXS that allow them to study the chemistry, the composition, what minerals are present, what the rocks are, and understand how those vary in space by the fact that it's roving off of the surface. In addition, there's a little drill that was enabled it to collect samples and bring it to the SAM and the ChemMin, which are inside, to get a more detailed examination of those rocks. And so I work on the APXS mission instrument. And so this is an instrument as shown here on the arm of the rover that examines rocks and materials on the surface of Mars. It stands for the Alpha Particle X-ray Spectrometer. But basically what the APXS instrument does is that it irradiates, it bombards the surface with radiation, so X-rays and alpha particles. And those come from these sources and they interact with the rock. You could sort of think about this as sort of being similar to when you go get an X-ray at a doctor's office, but instead of imaging, simply just imaging for features within bones and human bodies and things like this, the X-rays in this case are being concentrated on the rock for a prolonged period of time. And what this does is it excites and energizes the rocks on the surface. And in doing that, instead of just getting an image, they actually emit X-rays from the rocks themselves. And so those come back up into the sensor and are detected. And by studying the X-rays that are coming off the materials, we can get a sense of what their chemical composition is, what are they made of, how much calcium is in it, how much iron, sodium, things like this, so we can get a sense of what the rocks are made of and how they vary in different times. And this is super helpful because it allows us to classify and identify different geologic units. And so the rover landed in that basin in Gale Crater, and because it only travels very slowly at about 0.1 kilometers per hour, so quite slow, it's traveled 33.5 kilometers, and it started in the basin and has been coming up Mount Sharp. So to give you a different view in 3D, you can see in the ellipse at the bottom, the landing ellipse here. This is where it landed, the NSL Curiosity Rover, and has been making its way up Mount Sharp for the rest of its time over the past decade. And the reason it's going up the mountain is because in geology, when we come across different layers, they indicate different periods of time. And so we can look at Mars through time and see how that environment has changed. And from the mission, we have been following that piece of water that I've been talking about. So here, while this may just look like a regular rock to many of you, what's really cool to the scientists on the mission are these lines. So these lines that you can see here, and you can see that they change direction. And to geologists, we call this as crossbedding. And so what this is for example, is that loose sediment has been deposited as water has been moving as waves and ripples. And so by studying Gale Crater, we get a sense and an understanding of the role water has played in the environment. And the mission has been a great success. It was able to identify and achieve all its mission's objectives within the first 2 years of operation, and has since been exploring and coming up Mount Sharp. But here in this image, what they've been able to show was by studying it, by studying the chemistry, the different rocks, and imaging the different types of rocks, they were able to determine that the extent of some ancient streams and lakes and deltas present at Gale Crater. And so here the scientists believed that the water was infilling and evaporating over time, filling and drying over the periods of tens of millions of years. And that's really exciting, as I mentioned, because if the water was present, perhaps we have a habitable environment where life could have existed 3 billion years ago on the surface of Mars. And so by using the APXS instrument and the other instruments on board of Curiosity, we can get a better sense of the different chemistry. And this is where the rover is currently. This is a panorama image, similar to what you can do with your cell phone. The rover takes large panorama images for strategic planning and identifying where it is on the surface. And it's in a place called Geddes Vallis, which is a channel that formed down the formed by liquid water flowing debris down the center. And so this is an exciting place, once again, because we have water. And from the APXS instrument, we can see that water is interacting with the rocks. So there are things called sulfates, which are salts that form with sulfur. And these form as you start evaporating water. And so you have these flows of water, you have these lakes forming, and the water is evaporating over time. And as it evaporates, the water gets saltier and saltier and saltier until those sulfate salts start to pop out. And that's what they had been seeing for a lot of locations in this area. But then suddenly, the rover was exploring a specific reason. It was trying to look at some of the rocks, and it rolled over this spot. And when it rolled over the spot and reversed, it actually cracked the rock. So you can see all these fractures in it, and what that revealed are these crystals within inside. And so within the crystals, they found pure elemental sulfur. So this isn't the salts made of sulfates, but just pure sulfur. And we often associate sulfur with that rotten egg smell here on Earth, but pure elemental sulfur is actually odorless. And so what this tells us is about the extreme environment by which this sulfur would have precipitated out and formed. And it was because of the APXS instrument, because it's one of the best instruments for detecting sulfur, that they were able to analyze it and determine that it was pure elemental sulfur just last year. And so that's not the only thing that's exciting that's happening on Mars, and space agencies are always looking forward. And so while Curiosity has been exploring the surface for the last decade, over a decade, NASA has sent a new rover to the surface called Perseverance, and it's currently exploring Jezero Crater on Mars. And the reason they're interested in Jezero Crater is the this delta fan that you can see right in the image. Because on Earth, we know that these deltas form associated with large rivers, such as the Mississippi River, the Nile Delta, or the Fraser River Valley in BC. And so once again, we have this idea that water would have played a key role in this area in the past. So much so that we believe that it probably filled the crater up in Jezero crater and had an in and an outflow of water coming in and out. And so they believe this is a great site and for the chance to life exist. And so NASA, in partnership with ESA, sent the Perseverance rover. This is very similar to Curiosity, it's slightly bigger. But in this mission, they are collecting samples with the aim of sending them back. And so this is really for future generations, for you listening. So they're collecting samples currently, and they're going to send them to a lander that will launch them back to Earth. That way we can study them in our laboratories and look what is the chance for life to have existed or exist on Earth. And the Canadian Space Agency is funding Canadian scientists who are actively part of the mission, helping to decide which rocks are collected so that they'll be sent back. And hopefully in the future, young scientists like yourself will be able to get involved and help us understand Mars, the dynamic nature that it is, and the story of life in our solar system, and if it's just on Earth or elsewhere in our solar system, which is really exciting. So I think that's all I've got for today, so I'm happy to take any questions, and we can go from there.
Fantastic. Patrick, thank you so much, man. What a deep dive into Mars. That was awesome. Before we dive in with questions, and I know there's already some pouring in on YouTube, which is awesome, we are going to do our little Kahoot together, test some understanding, have some fun, see who is paying attention to some of the main themes there. So Patrick, if you're new to Kahoot, the faster our audience answers, the more points they get, and what they win is our everlasting respect. And so if you want to give any hints as we near the end of the 20 seconds in each of these questions, we'd love to have your support as we go into this, but we're going to dive in a second. There's already 47 of you in the Kahoot. Please do sign in. You can use that game pin 307-4344, and then we are going to go to Mrs. Beck's class for our first question when we dive in with Q&A. But let's get started. You guys can keep pouring in as we go. We've still got a few more seconds. Let's do this thing together. All right. I'm excited. This is so much fun. All right, question one, folks, in 3, 2, 1. Let's see, Mars is how big compared to the Earth? So we highlighted this. We had a few different graphs and things. We talked about this early on in the presentation. Is it about half as big? Is it exactly the same size? Is it twice as big? Or is it 1/4 the size? What do we think? Patrick, any hints for our audience today?
It's definitely, try and think, smaller is always best.
Smaller is best, and people really did a good job at this. So most of you got this right. It's about half as big. A quarter is more like our moon, twice as big. There's no planet that's quite twice as big as the Earth, but those who were listening did a very good job. Glowing Puffin takes our lead. All right, question 2. How many rovers have successfully been to study Mars? We talked a lot about Curiosity today. Is that the only rover that's been? Has there been 5 total, 20 rovers, or like 100 rovers? Are we just like sending rovers all the time? I wish every scientist.
That would be great.
Yeah, I know. So, wow, 150 of you. Holy, so many people in the Kahoot. This is amazing. Let's see. What's our final tally? 5 is correct. So we're still working on other missions. We talked about some of those future missions, but most of you got this right. This is a bit of a tricky one. 5 rovers have been on Mars. We've had a few landers as well, some orbiters. So Mystery Stork takes our lead barely over Agent Elk as we go into question 3. All right. Mars used to have flowing water on its surface. We talked about this a lot. So what do we think? Let's see. This is a picture, by the way, of the Tablelands, which is like right down the road from me in Western Newfoundland, which kind of looks like Mars, but isn't. So there you are. Wow. This is our biggest Kahoot of the year by a big margin. This is great. 215 of you in. Way to go, everybody. So yes, true. We have these river deltas. We have these really amazing features on the surface of Mars so clearly are created by water. And so it's been one of the big discoveries over the last few decades. And most of you were on point. So I'm going to skip our leaderboard for a sec. This final question is not There's no points for this. I just want your thoughts. Optimism or pessimism? Will we one day walk on Mars? Yes or no? What do we think? And I want to stress, Patrick, you mentioned this. The students in today's classes, like you guys are the age that would be the people to do this. Like if you're keen on this, as we continue to invest in exploring other worlds, both with robots and with people, like it's our school age audience that might be the people to do this. But let's see what they thought. Most of you are about more than 2/3 of you say yes, and then 81 of you are like, no way, we're sticking on Earth. What's the point? I don't know. Well, I'm certainly on the optimistic camp. Let's see what that does for our tally. And then Mrs. Beck, if you want to flick on your mic, we'll come to you for a question to begin. YouTubers, share yours. Miss Collier, you're going to be next. And our winner, barely by 8 points, wow, that's a close one, is Great Lobster. Well, thank you so much for playing, everybody, and glad to see your optimism for Mars. Mrs. Beck, I'm going to head to you guys to start us off with a question. We're going to head to all our live classes, so get those questions ready, everyone. You're in. You're a voice in the ether, Mrs. Beck.
Okay, Umar, go ahead.
How long ago did humans explore and heard about Mars?
Ooh, that's an amazing question. So we've always been curious about Mars. We've known about its existence, even from ancient astronomers. And then in the medieval ages, we started to use telescopes, and then we began to study Mars in greater detail. And those channels that I was talking about were actually some of the first things that people started to study. So even in the medieval ages with rudimentary Renaissance telescopes, they started drawing and mapping them. And they saw these lines, these linear marks, and they started saying what caused them. And so they called them the Chinalis in Latin. And so we've always been curious about Mars, and we've been exploring it for a really, really long time.
Patrick, what a beautiful answer, and some cool history in there too. Thanks, man. Miss Collier's class, we're gonna head to Chestermere, Alberta. If you guys want to unmute your mic, you are good to go, and we'll bring you in for a question. YouTubers, some great ones already in, which is fantastic. I'm gonna come to both of those that we've got so far, but Miss Collier, hello.
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 Okay, Carter, what is your question?
How long can astronauts stay in space for?
Ooh.
Well, so that's a really, really good question. So far, we've mainly been exploring with the International Space Station. And so there they spend months to a year in space before coming out and switching. In terms of limits, what we have to do when we explore these bodies with humans is think about human health. And so these environments are quite hazardous for humans, because there's a lot of things like radiation and supplies and things like that. So as we look further to exploring Mars and putting humans on Mars or going to the moon, back to the moon, we're testing how long we can put humans in space. So for like the Apollo lunar missions, there was days in space. But if we want to go to Mars, they'll have to be able to survive that 9-month journey, and then they'll have to live on Mars for a long time before they come back. And so we have to do a lot of tech development and advancements before we can make sure that our astronauts are safe as we explore deeper and deeper into space.
Great answer, Patrick. And on the health note, I love a question on YouTube, so I'm going to head to it really quick. So Miss Cross's class, Herbert H. Carnegie Public School, they want to know, what would happen if you went to Mars without a spacesuit, Patrick?
It would not end well for you. It would be really, really dangerous, and I wouldn't advise it. The atmosphere is very, very thin and mostly made of carbon dioxide, so you wouldn't be able to breathe. And unfortunately, as I mentioned, there's no liquid water present on the surface. And that is because the atmospheric pressure isn't large enough to keep liquid water stable. And so water would literally come out of your body, and it would not go well. So you need a suit. You need pressurized suits.
You certainly do. But on that note, if you have that suit, our Miss Piercy's class wants to know, could it be inhabited by humans? So if we have the gear, if we have the technology, we can go to Mars and live? Yes, in theory?
It's certainly, as with all space exploration, and this is actually one of the great things I love about space exploration is that it has a lot of challenges. Mars is certainly not the Earth. There is only one Earth, and we only have one home. And so there's a lot of difficulties with habiting and living on the planet. For example, oxygen is a huge issue. We need oxygen to breathe and exist. But NASA has missions like the Perseverance rover that actually had an experiment of it that was able to convert CO2 in the atmosphere to oxygen in small quantities that maybe humans could use in the future. And then we would just need resources like water, food production, and things like that. And so these are all areas that space agencies, national space agencies, are exploring to development so that we can exist in space. Food production and health, astronaut health are key areas that are being advanced so that we can exist and inhabit these extreme environments.
Patrick, you are uniquely good in Q&A. I need to have you back on anytime. That was fantastic. I will recommend, there's a fantastic sort of graphic story around it called A City on Mars by Zach and Kelly Wienersmith that is like by far my favorite book on the sort of logistics and difficulties of living on Mars. So I really encourage that, especially for our older students today. Really worth checking out. Ms. Boulos' class, grade 6, come on up, unmute your mic, and we're going to head to you. We're going to take as many questions as we can. All our live classes, we've got a bunch more on YouTube over the next 10 minutes together. So welcome in, grade 6. Hi.
Hello. I was wondering, how long did it take to create a robot?
Ooh.
Oh, well, so it really depends on the mission, but it takes years of development because we want to make sure that it works. These are big national investments, and we want to be able to make sure that we can do the science that we get there. And so we take a really long time to develop the instrument, build it, and make sure it can fly. And so that includes strategic planning, and so it can take many, many years to develop both the instruments and the rover.
I love when we get these questions because I think when you're a student, the idea is of doing a big project, it being like, a few weeks or a month. And with Mars missions in particular, it can be decades of your life. We actually regularly feature a NASA scientist who literally went in as like a 16-year-old student to watch the Opportunity rover take off. And by the time her career, she's in the middle of her career now, but she was the chief scientist on it. Like this was like a 15, 20-year mission from origin and development to it still going around on Mars. So great question, guys. Mrs. Parrish's class, we're coming to you. Come on up, 6-7s, and take us away. Hey.
What will we do with the information we learned about Mars?
Could you repeat that, but a little closer to the camera? It's hard to hear you. Sorry.
What will we do about the information we have on Mars?
Nice. What are we going to do with all this stuff that we're gathering, Patrick, and the info that we have?
So the really great thing about national space agencies is that all the data and information that we collect through missions like Curiosity and Perseverance all becomes public. So as was mentioned, you can go download all the images that you want. You can go download all the APXS data. You can get it from all the instruments. It takes about 6 months, but it all goes online. And that's because all these investments and opportunities are for the public and for expanding our scientific knowledge. And so what we do with this data is we give it to you. We give it to future scientists, current scientists, so that they can study it, and you can tell us what Mars' secrets and history as we keep going. There are scientists on the mission that will use the data to explore and publish in the time. But after that 6-month window, a lot of scientists get involved from around the planet, from Canada, from the United States, Europe, all over the place, to use this data to really advance our understanding. It isn't locked up and put in a box. It's really for the public and for scientists, whoever has the best ideas, to come forward.
It's one of the great things about space exploration. It's one of the great things about Antarctic exploration too. Like we have sort of this continent set aside for science on Earth and sort of reflects what we do in space, that really it's such an international community of experts like Patrick that get to work with the coolest people on planet Earth, travel for their job, bandy about these great ideas all the time. And so I love when we get that question. Thanks, Mrs. Parrish's class. All right, Division 2 at Drinkwater, unmute your mic, come on in. Our grade 6E crew, you guys can share in the chat as well. We'll take like 4 more questions total. I know we could go all day, but time flies and you're having fun. But Division 2, take us away. Hey.
Hello.
So my question is so we have VR, virtual reality, and everything, and so why don't we build like a human-like robot and use a full suit virtual reality suit to mimic human stuff while on Mars, so you can have tools and stuff, and it's easier for everything to do and to pick up and everything. So actually, humans technically are still doing the work, and it's actually a bit easier for everything else.
We have never had that question in 10 years of exploring by the seat of your pants. So thank you very much for that. And Patrick, take us away, man.
So virtual reality and augmented reality is actually a really cool area that space agencies like NASA are really actively hoping to use as they go back to the moon and explore Mars. So one of the really cool ways that NASA is looking at virtual reality is even as they send humans back to the surface, is making it a virtual reality or augmented reality helmet, and then using virtual reality to help with mission planning. So you can visualize where you are on the surface, look at different objects and where they relate, and do things like that. So yeah, we're actively exploring, or space agencies are actively exploring how virtual reality can be used and how they can use it in the future. And it's a really promising area, and hopefully they'll be able to use it in similar ways to the ways you described, because it's a really cool way to, situate yourself and make it more real for us on Earth when we're looking about these places.
What a neat question. Thank you so much, man. And we're going to take just two more. I know we could go all day. I'm going to pass along some resources. So I know we're at the 42-minute mark. I really encourage you. The Canadian Space Agency has a great Mars website. If you want to learn more about Curiosity, NASA has an amazing website as well. We'll link those into the email that goes out at the end of the broadcast to everyone. We've also got another amazing program with the Canadian Space Agency, February 10th at 12. So do check that out as well. And this one will be on our YouTube channel if you want to check it out and learn more. But we're going to take one more from our 6E crew, and then I'm going to YouTube to Miss Gibson's class, who's asked so much. Our 6E crew wanted to know about what time will we be moving to Mars as humans, Patrick. When are we going? What's going on? Tell me more.
As I mentioned, there's a lot of work that needs to be done, a lot of technology that needs to be developed, but it seems like it's something that humans want to do. When it actually happens, I'm not sure. Some people have said the 2030s, maybe the 2040s, but it really is dependent on, how we advance our technologies that we use and making sure we can keep astronauts safe. So once we can do that, then I'm sure it will be the next sort of the step in our cosmic journey.
I hope that one of the kids in these classrooms are the astronauts that go there, and then we can feature you in the future. So in the future, kids, if you are on Mars, please consider exploring by the seat of your pants. We'd love to do the first live broadcast with you. Miss Gibson's class, you guys have asked so many great questions. They wanted to know, can you tell us again in miles how far Mars is from Earth? And I want to highlight that the journey with a spacecraft to go from Earth to the moon is like 3 days, and Mars is like 5 to 8 months. So it's a really, really long distance. Patrick, thanks for bringing it up in the slide.
Yeah.
Go for it. Tell us more.
So yeah, it really depends on the orbit, where Mars is and where Earth is. But where at its closest point, it's 56 million kilometers. And then when Mars is furthest from Mars, it's 400 million kilometers. And this distance has implications for sending stuff there. It takes, months to get from Earth to Mars when we launch stuff, not like when we go to the moon. And also it has implications for how we command these rovers, because there's an actual delay in the time it takes for the signal to get from Earth to Mars. So you can't drive a rover on Mars like you can on the moon, because on the moon it's a couple seconds, so you can particularly do it like how you could do with a drone or a remote control car almost. But with Mars, that delay is like 20 minutes. So you can't have it so you push something forward and then wait 20 minutes. And so it affects how we operate on the surface and do things with our mission planning.
We had a few questions like that in our YouTube chat, so I'm really happy you covered that. It's not an instant response because literally space is so big, it takes a while for that signal to get there. Patrick, do stick around when we're done the broadcast. I'd love to chat with you for a second. In a minute, we're going to bring in all our classes to say a big thank you and farewell. And classes, stay tuned for an email too. I'll pass along all sorts of extra info and a cool little survey if you're willing to fill that out for us, just about 5 minutes. But before we wrap up, is there any final message you want to leave our kids with about your work, about the space agency, our exploration of Mars, anything before we say farewell?
No, I guess what I would just encourage y'all is to, keep following your dreams and explore different opportunities. Find what you're really, really passionate about. If you like space, space is really, really interdisciplinary. You can come at it as an engineer, a scientist, a biologist, a geologist. So just find what you really, really love doing and then pursue it and all the different opportunities you want to do.
No better message than that. Thank you so much, Patrick. And as we do to wrap up every program, I'm going to bring in all our live classes to say a big thank you and farewell. So Ms. Bullis' class, Mrs. Parrish's class, Division 2, Ms. Beck, Ms. Collier, thank you so much, everybody. Have a wonderful day. Bye for now, guys. See y'all soon. Thank you.